Hi, everybody, and welcome to our Dev Talk. James Swinton Bland is talking today about our HD4000, and I am going to give it a minute here for everybody to jump on, but we're waving hellos to everyone, and thank you for joining us. Give us a minute or two, and we'll let everybody hop on, and then we'll start. Okay, awesome. Hello, everybody. How are you today? Hope you are well wherever you are at and whatever time zone you are in. Thank you so much for joining us. It's our monthly Dev Talk, and we're excited to bring you a talk from James, who is standing by. I just wanted to do a few things on housekeeping rules before we get started. First thing is, if you are not part of our community, please become part of our community. It's completely free. It's developer.zebra.com. Join us anytime. There's a lot of information for you there on the developer portal, information on this particular talk. We have all of our papers and all of our blogs, and you can ask questions. So just about anything that you're working with or developing, we can certainly support you in whatever way possible. So please feel free to join our community. The other pieces of communication that you'll hear from us on a monthly basis are our Dev Talks, as we're doing here today. On occasion, we have Dev Talks community days in the regions a couple times a year where we have kind of a full day of Dev Talks, and you can hop on and hop off wherever needed. We also have our monthly DevBuzz newsletter, and we would for sure love to have you as part of our community and receiving that DevBuzz newsletter. It's free, and it will just highlight anything developer related. It's very specific to that. And also, follow us on Twitter, LinkedIn. We have a private community group, and we would love for you to join us. It's the Zebra Developer Community Group. Just join anytime. I monitor that. I'm happy to have you participate, GitHub, and then of course our portal. So with that, just a couple of other rules for today. We're going to take questions at the end, so you can just post those in the chat, or the Q&A rather, and I'll just address those at the end with James. Next slide. And we're very, very excited to announce Zebra DevCon. We're going back to our roots. Some of you may have participated a couple of years ago in App Forum or in years prior. We've rebranded this, we've revamped it, and we're going definitely back to our roots on the developer end, and it's called Zebra DevCon 2021. We're really excited to launch this event. We're going to have it for, save your date. It's about 8 to 2 in your time zone, so think of it as your own personal event in your own personal region. APAC is on the 3rd, EMEA on the 4th, and NALA is on November 5th. We're going to have some really exciting keynotes from some of our Zebra leaders, Kambi and Cooley, and Suresh, and then we're also going to have some talks from Microsoft, Google, and of course all of our Zebra experts. And there's a very special guest that's going to be there, Mandy Hickson, and I think you'll want to jump on and listen in when you can. So that event is free, and you'll be able to register very soon. So please watch our portal and watch all of our communications, and we'll go ahead and announce that in the coming weeks as registration opens in September. And with that, I'm going to turn it over to James. You are on deck, and good luck, and thank you so much.
Perfect. Thank you very much, Stacey, for your lovely introduction. So welcome everyone. Good morning, good afternoon, good evening, depending on whereabouts you are located. So this session is going to be covering the SDK for the HD4000, specifically version 2 and the updates included in that new version. So my name is James Swinton Bland. I'm the developer advocate for EMEA here at Zebra Technologies. I've been with Zebra for just under 3 years now. It's my job to work internally, developing applications, proof of concepts, and demos using our SDKs and our APIs, and also to work externally in order to help customers, partners, people like yourselves to get the most out of our hardware and our software. So I'm primarily an Android developer, but try and help out in all development languages where I can. So anyway, enough about me, and let's get into today's content. So this is the agenda for the presentation today. So the first thing I'm going to cover is just migrating to the new SDK. So this is applicable whether you've used version 1 of the SDK or not. There's a couple of prerequisites that we're going to need to meet. So obviously accessing the SDK and downloading it, the first step. Then we need to make sure that we've got the latest firmware running on our hardware, and also installing the latest driver, which manages the USB connections to that hardware for us. So once we've gone through all of that sort of housekeeping, we can call it, then we're actually going to talk about the APIs specifically. So we'll talk about how you manage your connection to the HD4000 inside of your application. So there's been some changes and improvements here from the first version. So the context dependency has changed, and we also have auto reconnect options as well. Then we'll move on to camera updates as well as display updates. So these two sections were pretty much the main focus of the changes implemented in version 2 of the SDK. So improvements to receiving data from the HD4000, so images, as well as sending data back up to the HD4000 and just improving the throughput and the performance. So specifically then capturing image and video, configuring the resolution of the camera and the various frame rates, and I'll also show you some benchmarking of those APIs. Same sort of thing with the display updates. So we'll cover the new APIs that have improved performance and throughput, and we'll discuss how you might go around sending video to the HD4000. So those first 4 sections are focused on the SDK. This 5th section will be around the intent-based service. So this is essentially an alternative entry point into the HD4000. So instead of leveraging the SDK, you can leverage this intent-based service. So we have an officially released version that's now Zebra supported, and we have a beta version which is available upon request from myself. But we'll talk about that in a little bit more detail towards the end of the presentation. And then the last thing I want to touch on is just give you a little preview of a maintenance release version 2.1 that we should have coming out in the next few weeks. So without further ado, then let's talk about migrating to the version 2 of the SDK. So the SDK was released a few months ago now, back in February of this year. It's available, as you would expect, for download on our support site. So in the same place that you can download all of our other SDKs and our BSPs and things like that, the HD4000 SDK is available there. All of the links that you'll see in this presentation, we can send out to you afterwards, so you can access these links. So that download there is a zip file. It obviously includes the SDK itself. It also comes with a firmware updater utility. So this is an application you use to update the firmware on the HD4000. As I mentioned, the intent-based interface is now packaged in that download as well. We have a number of demos for different functions. One of those is an API exerciser, and this is pretty much a one-stop shop for everything HD4000 SDK related. And you can test all of the functionality out in that APK. And of course, we've provided the source code as well. I'll actually be giving a quick demo of that in the presentation today. So if you're interested, that'll be coming in a few slides. And then, of course, the last thing that we also have is the Java docs, or the raw documentation for those APIs. So once we've downloaded the SDK and we've got it, then we need to make sure that the firmware is up to date on our HD4000. So essentially, we just need to install the firmware updater, which is included within the SDK download, and then we can use that APK to either upgrade or downgrade the firmware on the HD4000. It's a really quick and easy process. It typically takes about 10 seconds, and I will show you that in just a moment. Before I do, just want to mention that you also need to install the 615 driver. So this is essentially an application which manages the USB connection to the HD4000 and is what enables the APIs in the SDK. As mentioned, this is included in the SDK download file. So all you need to do is just install it, make sure you run it once and accept all the permissions, and then you can use this app to validate or verify the firmware and software versions that are running. So let's quickly just demo that very, very swiftly. So in this folder here on my device, let me just tap the screen, we have the service itself and then the updater utility. So if I tap on this here, we just need to confirm permission on the dialog. We can see there that I'm already running the latest version of firmware, but if I wasn't, then I would just need to tap here. provide it access, and now we can update the HD4000. So you don't get any on-screen feedback, or you do, sorry, get some on-screen feedback, and you also get some feedback in the HD4000 display. So it takes about 10 seconds or so there. The HD4000 will go through a reboot. Once it's complete, come back up there. So very straightforward for updating that firmware. It's a prerequisite before you can use this version of the SDK. And then just to confirm that everything's working as it should be, we can open this HMD service app. We can see that we're running the latest version, 5.43, and we can also check the information on our HD4000 to get the unique ID and importantly, make sure we are running the latest firmware version there. So very simple, very straightforward, but just something that you need to know in order to enable you to create applications with this new SDK. So once all that's done, the first thing you're going to want to do once you get your hands on the SDK is connect to the HD4000. So the V2 of the SDK, it now works with any context. Previously in version 1, you had to attach the SDK to an activity context, and you had to override all of your lifecycle callbacks and then call the relevant lifecycle callback in the SDK. So this was a little bit tedious, and there wasn't really a good reason for that. So we've decided to change that. And now we can connect the HD4000 to any context. So for example, a foreground service, such as the intent-based interface, for example. This new driver also allows auto resumption when the HD4000 is power cycled. So previously, if you were to take the USB out of the device and put it back in, a dialog would pop up. This new driver prevents that from happening. So essentially, we've replaced those lifecycle callbacks, so the on start, on stop, on pause, and on resume callbacks. We've replaced those with just 2 callbacks, which is attach to context and detach from context. So essentially, when your application is in a state where it needs to use the HD4000, you would call that first API. And then when you no longer need to interface with the HD4000, you would call the second API. So just to give an example of this, on the left-hand side, we have the legacy way of connecting to the HD4000. And we can see here on the right-hand side that we've greatly reduced the amount of boilerplate code that you need to include. So instead of calling all these lifecycle methods, you just call attach to context and detach from context. I've put these in on resume and on pause, but it's up to you essentially based on your use case, whereabouts in your app lifecycle you would call these 2 methods. So moving on then to talk more specifically about camera updates, we've essentially got 2 APIs for capturing images on the HD4000. So this first API here, Start Camera Capture, essentially converts the JPEG data into a bitmap, and then it will return that bitmap to you in this on-camera image callback. So in the previous slide, we had this attached to context API. We can see here the first parameter is just the context. This second parameter is this Zebra HUD events listener interface. So this is essentially where we're notified in our app of all events on the HD4000. So we can see there for connection events or disconnection, as well as when the data is updated on the HD4000. And then these 2 APIs here are where we receive the camera images from the HD4000. So if we call this API Start Camera Capture, as I mentioned, it will convert this JPEG data into a bitmap, and then it will return this data into this callback here. So you can see there you'll receive your bitmap. Essentially, this API will just send a stream of bitmaps down to this API at the highest frame rate that it can, depending on your configuration, which we'll discuss in the next slide. Just before we do, we also have this second API called Start Camera Capture Raw JPEG. So it functions in pretty much the same way as this API, but rather than converting the JPEG data to a bitmap for you, it just sends the raw frames to the application. So this is the callback method here, and we can see that the image is returned as a byte array. And in the same way, we've just received 1 byte array for each image, essentially around about 30 times a second, depending on your frame rate. So the data that is sent to this callback is taken from the motion JPEG stream on the UVC camera, and nothing happens in between. So the SDK doesn't do any processing to that image. So this API is slightly faster than this one above here. So if you're looking for the best performance and the most throughput, this would be the API that we'd recommend using. So, excuse me, previously in the version 1 of the SDK, we essentially just had the option to start capturing images and stop capturing images. In the version 2 of the SDK, we've exposed some more configuration options. So we have 3 new categories of APIs, which we're going to run through now. We can configure the resolution, the frame rate, and the zoom. But with some caveats. So the frame rate is only configurable for the 720p resolution. If you're running any other resolution on the device, then it's just going to default to the maximum frame rate. There's another caveat for zoom, and that is that it's only configurable for the 240p and 480p resolutions. If you're using any other resolution, then you just get one standard zoom setting and you won't be able to tweak that. So in terms of configuring the resolutions, we do this using 2 APIs essentially. So firstly, we need to query the available resolutions by calling get all camera resolutions. So we can see that down here, and that's going to return us a list of these objects called HUD camera resolutions. So inside of this list are all the different resolutions supported by the HD4000. Then we would just need to call set camera current resolution on an instance of the Zebra HUD object, which is what provides us access to the SDK, and then pass through one parameter, which is a HUD camera resolution object, which is the resolution that you would like to use. So this list is ordered, so the lowest resolution is the first one, and then the highest is the last one. It's worth noting then that the camera must be connected before you can query these resolutions. It's dependent on the hardware that you have. So the HD4000 must be connected before you query those resolutions. In terms of configuring the frame rate, given that the frame rate is only configurable for 720p, as I mentioned, these are stored as a static variable called zebrahud.listCamera 720p frame rates. So it's essentially an array of integers, and I can just tell you that the integers contained within that array are these values down here. So you could just hard code this if you preferred, and then you can just call set camera 720p frame rate and pass in the relevant frame rate that you would like. So these go from lowest frame rate to highest. So if you want to set the highest frame rate possible, just choose the last item in the list, or alternatively, just put the hard-coded value in there if you prefer. If you try and call or set the frame rate and the current resolution is not 720p, then the call is just ignored. It would silently fail. So something to bear in mind there. In terms of zoom then, we have sort of 2 APIs for this. So the first thing we need to do is get all the different resolutions, because the zoom is a property of the resolution. And then inside those resolutions, we can get the maximum zoom value. So this is going to be somewhere from -1 all the way up to 6. And you can essentially set the zoom value anywhere in between that minimum and maximum. So we set the zoom by calling set camera zoom and passing through the integer here. So just to reiterate, zoom is only available for 240p and 480p resolutions. So in terms of some benchmarking we've done, this is what you can expect to get for these different resolutions. So for the 2 lowest resolutions, they're 240 and 480p. As I mentioned, you can configure the zoom. So you have options from 1 all the way through to level 6 zoom, and you're going to get somewhere around 30 to 31 FPS when you use those resolutions. Essentially, it's a trade-off from there onwards. If you want a higher resolution, it's going to come at the cost of a lower frame rate, essentially, and it's a sliding scale. So you can see as the resolution increases, the frame rate decreases, as you would expect. So the maximum frame rate that you can get from the 720p resolution is 24 to 25, but of course, it depends on what you set that frame rate as. And then we've got around 10 to 11 frames per second for 1080p, and then 8 or 9 and 6 and 7 respectively for those last 2 resolutions. So that's the camera updates covered off. So now let's talk briefly about some of the updates to the display APIs. So there are 2 new APIs available now for displaying images on the HD4000. And that's these 2 APIs here. So show JPEG direct and show bitmap direct. Essentially, they do pretty much what they say on the tin, and they either show a JPEG or a bitmap on the display of the HD4000. And if we compare them to these two, I don't want to call them legacy APIs because they're still supported, but two of the APIs that were available in version 1, we can see there that we've had a very, very dramatic increase in performance between these two APIs specifically. So show HUD view here is an API which is used for displaying Android layout files as images on the HD4000. And then the show image API is essentially just for showing bitmaps. So it's functionally comparable to this one here, although show JPEG direct does pretty much the same thing. So essentially, if you're looking to send content to the HD4000 at a fast and reliable rate, then I'm going to recommend, heavily recommend that you use this show JPEG direct API, as that's the API that you're going to get the best performance with. Just one thing to bear in mind, this benchmarking that I've done here doesn't factor in any costs or time associated with creating the bitmap or the view. So when we show the JPEG direct, we can just pass through a byte array, which doesn't really take any pre-processing. If we were to convert that byte array to a bitmap, for example, before sending this API, that part of the logic has been excluded. So you could expect this number to grow as you would with the HUD view, because you would need to inflate the view, and the same with the show image API would have the same issue as this show bitmap direct. So just something to bear in mind, but the point to reiterate here is that the show JPEG direct API has significantly improved performance. So a question that I get quite commonly for the HD4000 is how we would go about sending video to the HD4000. So unfortunately, we don't have a direct API for video support. Essentially, if you want to send video content to the HD4000, then you need to do it frame by frame using the image APIs. So you can use any of the APIs that we discussed on the previous slide, but of course, I'm going to recommend show JPEG direct because it's going to give you the best performance. So in terms of splitting the video into individual frames so that they can be sent up to the HD4000, if you're just looking to get a quick little test together and you're not too worried about performance, then I'd recommend using the thumbnail utils from Android. They're not super robust or efficient, but they are very, very easy to use. You just put a timestamp in and the video, and it will return you the frame. So a very easy way just to get a proof of concept going. If you're looking for a little bit more performance, a little bit more speed, then I'm going to recommend something like FFmpeg or OpenCV, which both have Android libraries that are well supported. There is quite a steep learning curve for both of these technologies, however, but if you can grok it, then you're going to see pretty good performance from those libraries. Just one last thing to note on this topic, something that people try is to place a video view in a layout and then use the show HUD view API to basically take that layout with the video view and display it directly on the HD4000, assuming that the video view will play the video. Unfortunately, this isn't what happens. Under the hood, that API is essentially inflating the layout and then taking a picture of it and then displaying that picture. So you may get the first frame of your video or maybe the third or fourth, but unfortunately, you won't be able to play the moving content. So just something to bear in mind there. So that's quite a lot of talking, quite a lot of slides. So I just want to hop over then and sort of show this functioning using the API exerciser demo that's included within the SDK. So if I pop this open here, then we'll have a look at this application here. So this is the API exerciser demo, which is included with the SDK. You can see there when the device is connected, it just scrolls to the bottom and shows you all of the details of the connected hardware. And then you can see there we have essentially mappings for every single API that's in the SDK. So we have the ability to turn it on or off as you'd expect, and also increase or decrease the brightness and scale, which will affect all images and content globally. And then we can see here, we can start to test some of the APIs that actually send content to the HUD. So the first API we have is something called messages. It's basically just called show message. You pass through two pieces of text, a title and a message, and then it displays this pre-configured layout for you. So we can see here that this took around 91 milliseconds, or just a little bit more there if the content increases. And then we can sort of cycle through and see the performance variations. We have something called JIM here. So this stands for JSON Image Model. So this is something I've talked about in one of my previous presentations. So if you want to learn a little bit more about this, just Google HD4000 SDK presentation. And we talk about using the JSON image model. So essentially, this is functionality we have where you can design HD4000 screens using JSON files. You can then use the show JIM API and pass through that JSON as a string, and it will parse that string and create a view for you, like this, for example. So we can see there that takes slightly longer than the messages API as we'd expect, because there's some parsing that needs to be done. And we can just loop through there and see the different views taking different amounts of time. So we'll just clear the display there, which removes all of the content on the HD4000. And now we can demonstrate the differences between these two images APIs. So this images API button on the left will send the images to the HUD using the version 1 APIs. And then this button on the right will send using the version 2 APIs. So if we tap here, we can see that this image took around 98 milliseconds to display. If we use the direct API, for example, instead, we can see that that only took 4 milliseconds. So there is a very, very significant performance increase taking place there. If we tap this button again, we'll see the show bitmap direct API. And we can see there that even though it's significantly quicker than the version 1 APIs, it is slightly slower than the show JPEG direct APIs. If we tap this button again, we can change the images and we can see them functioning with different images, and we can just loop through and see the sorts of variations that we get. So we also have the ability to turn the microphone on or off. We don't have any APIs for controlling the mic. They're just, it's controlled using standard Android APIs. The microphone functions as any other external microphone would. So now we have the camera section here. So we can see that we have the option of which API to use. I'm going to leave this ticked because that's recommended. And then we can see here we have the different configuration options. So if I just start with the lowest resolution, we can see there that we don't have the option to configure the frame rate. And then we can start the camera capture. So let me just bring the HD4000 up. So there you go. I've just got it in my hand. I haven't got it attached to any glasses because it's easier to demo this way. And if I start this camera capture, we can see that that is coming through at around 30 frames per second. And this is sort of a live view of what I can see from my desk. So we can change the view on this setting, on this resolution. So just for a dramatic effect, I'll go from the lowest to the highest zoom level. And you can see there that that functions as expected. There's a little bit of lag there. I think my PC is struggling a wee bit. And we can resume that back out to zoom 0. So if I stop the camera there, I can change the resolution. If we go to 720p, for example, and I set it to the lowest frame rate, if I restart the camera, we can see that that content is coming through, but fairly jittery, for example. And then I can stop there. I can change it to the highest frame rate. We can see there that we get much better responsiveness from the unit itself. Of course, I could also change that all the way up to the highest resolution possible. And there you can see that it is slightly clearer, but obviously at the cost of a much lower frame rate. So that's that functionality demoed. So the last thing that's included in the API exerciser is the IMU data. So we get here 5 different data points. Well, 4, I should say, as this has been depreciated. So we have accelerometer, gyroscope, magnetometer, and the current temperature of the device. And then we previously had quaternion vector, but as I mentioned, that's been depreciated. So if I just swing the unit around here, you can see that those values and variables are changing and all being updated in real time. We're receiving data about 10 times a second here, so once every 100 milliseconds. That is configurable, but that is the maximum rate. So we can turn that off now, and we can return back into our presentation. So that's pretty much the SDK covered off, the changes included in the version 2 of the SDK and sort of all of the functionality within there. So now I just wanted to spend some time talking about the intent-based service. So to give you a bit of an overview, essentially, as I mentioned, this is an alternative entry point into the HD4000, and it means that you don't have to use the Java SDK or any of the APIs contained within that SDK. So it runs as a foreground service on the device. That foreground service manages all of the connections to the HD4000 for you. It has all of the SDK APIs included in there. And then you interface with the service, or this intent-based service, using, you guessed it, Android intents. So those intents would contain information relevant to building the display on the HD4000. The service will receive that intent, extract that information from the intent, parse it and turn it into a view, and then display that view on the HD4000. So this is pretty much designed for simple use cases or for applications which want to leverage the HD4000 but either can't use the Java SDK or don't want to spend the time integrating it into their solution. They can leverage this instead for a much easier to run solution. So with things like Enterprise Browser, for example, which obviously can't use the SDK directly, this gives web apps a nice, easy entry point into the HD4000. So the officially released version supports displaying text, so both single and multi-lines of text, images, text and images all inside of a single call, so placing text on top of configurable images, and also displaying GIM, so as I mentioned, JSON image models or using JSON schemas to design HD4000 screens. So I'll give a demo of all of this functionality in just a moment. Before I do, I want to touch upon some of the functionality that's available in the beta version. So everything you saw on the previous slide is Zebra supported and officially released. Everything you see on this slide is available to test, but doesn't come with any guarantees, and you would just need to contact me directly in order to test this. But it does come with some quite interesting or maybe slightly more advanced functionality. So we provide the ability to capture an image with the camera on the HD4000 using an intent, and you can supply where you would like that image to be saved. The settings can be configured with an ini file, so things like displaying the buttons on the persistent notification, whether the service should launch on boot, and some standard sort of defaults for their HD4000. Interestingly, we also have the ability to register for raw IMU data, so that accelerometer, gyroscope, magnetometer data, etc. And you can also register for specific movement callbacks. So the service has taken that raw IMU data, and it has a fairly rudimentary algorithm for detecting movement based on that IMU data. So if you'd like, you could send an intent to the foreground service, to this intent-based service, and say, I'd like to be notified anytime the HD4000 turns left, and then you can perform an action based on that movement. So if you're displaying a slideshow of instructions, for example, to a remote worker, and they want to go through those instructions, but without using, their hands because they're tied up, then you can hook into these movement callbacks and move the slideshow based on their head movement, for example. I'm sure we can also think of lots of other use cases where that movement data would be useful. So without further ado, I'll basically just go ahead and demo this, because I think showing you it in action probably means a lot more than just talking about it. So just bring up my device as well as a command prompt, and I have the intent format saved as well. So the first thing you need to do is basically launch the foreground service. So this is the application here, HUD interface. If I tap this once, we can see the app will launch, close itself, and then it runs as a foreground service. So once you see this notification in your notification tray, then you know that the interface has got a connection to the HD4000 and is ready to start displaying some content. So the first thing I'm going to do is send an intent. So I'm going to send all of these intents via ADB through this command prompt, but you could just as easily do it from your application. So the first thing I'm going to send is called toggle overlay. And essentially what this does is it creates a to-scale mirror image of what you can see on the HD4000. So at the moment, no content's displaying, which is why you just see this yellow box, which is sort of the bounds of the HD4000 view. As we send the next couple of intents, you're going to see this populate. Anything that you see inside of this yellow box is also being displayed on the HD4000. Obviously, the screen on here is very, very small, so there's not much for me to be able to show you on here. So this is a handy little feature for demoing at times like these. So the first thing I'm going to show is displaying some text to the HD4000 via an intent. So we can see there, so the first bit's just sort of boilerplate ADB command. You can see there the intent action is display text, and we have all of these different extras which configure the text to be displayed. So you can see the color of the text, the background color, how it should be justified, and so on. All of this is documented in the SDK downloads. So it's got its own documentation included in there, so I won't spend too long breaking down these intents, but you can just see there that that's how you show a single line of text. If we wanted to send multiple lines of text, we also have an ADB command for that. We can see there that we're only restricted essentially by the bounds of our view, and it would be the developer's responsibility to make sure that those designs don't overlap the view essentially. We also have the ability to display images, so we just send through the path of the image on the device. So I just have an image here of one of our Zebra printers. We can see then that's displayed on the HD4000. If we wanted to display text and images in a single intent, we can also do that. We can see there that it will overlay the text on top of this image here. So this could be useful for showing images of certain things. A remote worker fixing a piece of machinery, for example, you can send a picture of the machinery as well as what action they need to take. Finally, just for completeness, I'll also show using a JSON image model. So this is doing basically the same thing as the above intent, but just using a JSON image model to do it instead. So those are all sort of the standard functions, the released functions of the intent interface. Everything I was showing you from this point onwards is beta functionality. So if you want to use any of the features that you see here now in a moment, then you just need to get in touch with me directly and I can provide you access to that. So the first thing I'm going to do is capture an image. So there's just one intent for this, and we need to provide 3 parameters. We need to provide a name for the captured image, where it should be saved, and we also have the ability to play a capture noise as well. So if I send this next intent, I'm just going to get the HD4000 ready here so we can capture our screen. And if I send this intent here, should hopefully get the image to capture. So I think I've got my device on Do Not Disturb, so I don't think it's playing the capture noise. But if I navigate into Files, and hopefully in here I should see HUD interface folder. There we go, and then the image has been captured. So if I send this intent again here, and we can see the different variables, and I change the file name from test2 to test3, for example, and capture a new image. I'll take a picture of this screen instead. We can see there, try that again. There we go, that the image has been captured, and that's just my desktop screen there. So perhaps a useful feature, certainly if you want to do some debugging or perhaps see what a remote viewer is seeing at certain times. So the last piece of functionality that I wanted to show, and I will just remove this overlay. There we go. So I'll just hide that now. The last thing I wanted to show is registering for movement callbacks in the HD4000. So in order to do this, I have what's called IMU data receivers. So this is just a test harness. Essentially, when this app is launched, it will send an intent to say it would register for all of the different movement callbacks. And then it essentially listens for broadcasts from the intent service when it's detected certain movement types, and then it will essentially vocalize those movement types. So let me just, apologies, I think I have that remapped. So let me open up this IMU data receiver. We can see here that this is all of the data that is being received from the HD4000, all the different IMU sensors on there. So we have our accelerometer, our gyroscope data, our magnetometer data, and as I mentioned, our quaternion vector data is not supported. So if I hold this here and then I move it to the left, we can see there that the toast message pops up on the device to say it's moving left. And also do the same when it moves to the right, and also up and down. There you go. So it's a pretty basic algorithm. So of course we expose the ability to push all of that raw data out. So if you had a more sophisticated algorithm you'd like to use, you can plug the raw data into that. But if you have a basic use case that you'd like to meet quickly, then this could be a good way to do it. So the last demo that I wanted to show is something called this HUD stock check demo. So that's not ideal. So let me try that again. That's because I have the service running. So that's two things trying to connect to it at once. So in this demo, essentially what we're doing is we've integrated Google's ML kit into this demo, and we're using ML kit with the HD4000. So ML kit, or machine learning kit, is an SDK from Google, which is used to perform recognition on different types of images. One of the APIs they have is for barcode recognition via live camera streams. And essentially, we've taken that API and used the HD4000 as the camera input to that API. And then that returns us the decoded barcode data. So in this sample, we're meant to demonstrate a retail worker, for example, going around a store, scanning shelf barcodes and being notified of the current stock that's available. So this top view, the one that's called camera view, that is the feed that's coming from the HD4000. And then the bottom view there that says HUD view, that is what the user sees in the HD4000 display. So I have a printout here of a couple of barcodes. So let me just put this down here. And then if I move this HD4000 camera and place it over one of the barcodes, we can see that's decoded in real time. And it just checks that against a database, a hard-coded database in the app. And it basically gives an indication to the user of what the current stock level is. So for this barcode, it thinks it's tinned tomatoes, and it suggests that there's no stock remaining. If we were to move up here, pick the middle one, we've got Hovis white bread, and it's currently low on stock, so it needs replenishing soon. And up here we have 6 pints of milk, which are currently well stocked. So a pretty straightforward little demo, but we can see that the ability of using this HD4000 with other SDKs in order to provide more improved functionality. So I have all of the source code available for that if anyone would like to try it on my GitHub. That's github.com/James Swinton. So finally then, just before we finish off the presentation and go over to some questions, I just want to give a very, very quick preview of version 2.1. So in this upcoming release, these are some of the changes that are going to be made in this version. So to be more compliant with the latest versions, we now require camera permission to access the camera. We provide screen mirroring out of the box in the service application. So that app that we showed you to begin with, where it manages the connections to the HD4000 over USB, there's an additional option in there in order to do screen mirroring and also presentation mode. So presentation mode can be useful if you're using the media projection APIs and you would rather use those and have the HD4000 act as a second screen. Then you can place it into presentation mode and use those APIs with it. There's also reduced power consumption, so the HD4000 pulls all of its power from the USB cable and subsequently from the device that it's connected to. So we've improved some of the power consumption there. And also, as you would expect with any maintenance release of an SDK, we've also provided various little bug fixes. So that actually brings us to the end of the presentation. So just a few handy links there to some of our different social media sites. Thank you very much for your time and attendance. If you've got any questions, I'll be happy to answer them now.
That's awesome, James. Thank you so much. We do have one question here. Hang on. Is there any restriction on Android version, especially saving pictures on an SD card would be challenging on A11, isn't it? And will we support A8, 10, and 11?
Okay, A8 and A10, the answer is yes. Android 11, so this new maintenance release, version 2.1, from the OEM, there is a statement that it has Android 11 support. From a Zebra point of view, we aren't testing the compatibility with Android 11, and we currently don't have any devices which are certified with the HD4000 that are running Android 11. So if this is something that you would need on the latest version, Android 11, and you have a particular opportunity, for that, then please get in touch with me and I can try and send that back to the HD4000 team in order to get some more official support. So tentatively, 2.1 may support Android 11, but officially from Zebra, that is not something that we are certified just yet. So we'd need your opportunities in order to influence that. In terms of the question about saving images on the SD card, yes, on Android 11, that certainly would get a little bit more complicated. You may have to save it into your own scope storage directory, or you may need to leverage something like the manage external storage permission in order to give your app access to the SD card to save the files there. At that point, I would say that that's more of a standard developer responsibility to figure that out, and that's sort of a separate issue from the SDK. But yeah, certainly that may be an issue in later Android versions.
Okay, next question. How can I get in touch with you to find out more about smart glass-based user authentication?
If you just send me an just send me an email. I can put that into the chat, and yeah, just send me an email with your questions, and I'll do my best to help and answer where I can.
Okay, and then just so everybody knows, you can always email developer@zebra.com, and I monitor that email box, and then I'll get it out to James or anybody on the team that can help you with that. So no worries on that.
Of course.
Okay. And then just a nice thanks. So all good here. If there's any other questions, you guys want to post them in there right now. Just kind of hanging and waiting for your questions at this point. This presentation will be recorded and it will be posted on our YouTube developer playlist. And then we'll post it, of course, in the portal as well. But you can always get to all of our data or all of our content via the YouTube playlist for all of these dev talks. It's always posted on there. It takes a little bit to get up there, but we'll have it on there for you. Let's see. Question, can we communicate with the HD4000 from a progressive web app?
Yeah, so if you wanted to do that, then you're going to have to leverage the intent-based service, unless, of course, your progressive web app can integrate the Java SDK, which I'm pretty sure it won't be able to do. So yeah, you would have to run the intent-based service and then communicate using intents from that PWA.
Okay. And is it easy to create new voice commands for the smart glass?
Well, essentially, it would be the same as creating voice commands for any other microphone-enabled device. So, as I mentioned, the microphone functions as a standard external mic. So if you wanted to pull the voice from that and convert that into some sort of command or action in your app, then it would be the same process that you would follow for any other external microphone or any microphone for that matter. So I don't think that's a HD4000 specific issue or challenge per se. It's just more of a generic one.
Okay, and then someone asked, Leonardo asked, where can I get the demos with barcode detection?
Sure, I can put a link in the chat to that. It's
Okay.
essentially available on my GitHub. I will go and find the link now, so just give me a moment.
While James is getting that, any other questions to our audience out there?
There we go. So I've just put the link to that demo that I've showed in the chat there. So
yeah, it's up. Thank you.
I think I've been sending that to organizers and panelists only. So let me resend that.
I can send it through the question and answer. Hang on.
Yeah, please do. Thanks, Stacey.
Sure, will do. And then I will also send through your email, but again, please feel free to contact us at developer@zebra.com as well, that email address. Either one, we can get you in touch with James or anybody else on the team. Okay, and with that, I think we can wrap it up. James, this was really helpful and very good. So I appreciate you presenting today for our audience, and thank you to our audience for attending. Again, I've put some things in the chat and also in the questions to everyone, just to make sure that you have it. Zebra.com/devcon. Please go there as we develop more information about our agenda, our schedule, and our list of speakers. We'll have information on that page for you, and we'll have it on our portal. Thank you so much, everybody. Really appreciate your attendance. James, thanks again. And with that, we'll wrap for today.
Thanks, Stacey. Thanks very much for organizing and hosting. Thanks, everyone, for attending. I hope it was useful, and we'll speak to you all soon. Enjoy the rest of your day.